All right, another round of physics. Yay. And here we go. For the first one, observe that the light exits at 90 degrees angle to the normal. So we are dealing with critical angle here, of which you can use sine c equals 1 over n. Now, taking note that this is 90 degrees because the light did not bend. Which tells you that this is 90 and this will be 50. And because this is 90 degrees, so this is 40. So your C is actually 40. And you can find your N from here. And I'll give you the answer. Okay, next. 18 cm, focal length, 1F would be 15 cm, 2F would be 30 cm. Now 18 cm is between that. All right, so if you are between F to 2F, if you look at the table, for this you will get real, you get inverted, okay, but you will get magnified. Okay, if you're more than 2F, if the object distance is more than 2F, then you get diminished. All right, so that's in the table, the lens table. N of one medium. Okay, interesting. A medium could be anything that is solid, liquid, gas. Boy stands 2 km away. All right, this is quite simple lah. Just take 2000 divided by 6. And then I'll give you the answer. Feels like a 3333 kind of thing. Yeah, and that tells you this is air. The medium is air. Frequency F1 enters the water as frequency F2 and lambda 2. Water is denser. Okay. And the thing is, when sound enter a denser medium, the speed will increase, which is opposite from how light works. So light speed will decrease when it enters denser medium. For this, the sound speed will actually increase. Okay. The reason being is because the particles are closer together, which means that you're able to transfer the energy faster. So the speed will increase in denser medium. The F remains the same. Frequency depends on the source. So you can try this. You can make a note like ah in the air, and then you go into water and you make the same note ah, and then you realize, hey, no change in the frequency. Try that as a homework. Go and find a pool of water. All right. But importantly, be safe. So if your speed increases, but your F remains the same, your lambda will thus increase. Okay, your lambda will be more. So this will be the answer. Because your frequency is constant. Okay, moving on. If you zoom in, that's four wavelengths. So your lambda is then 0.15 divided by 4. And you have a frequency of 30 hertz. So V equals to 0.15 divided by 4 times 30. Yeah, and they'll give you the answer. So I think it's B. I'm not too sure. Calculate out the answer. Okay, I'm using V equals to F lambda or lambda F lah. So as you are traveling to shallow waters, you'll be more spread out. Deeper waters will be more spread out. That's because you have more space to work with. So it's just that. So it's A. We are looking for incorrect one. This is correct, correct, correct. Their frequencies don't change. Remains constant. Frequency depends on the source. Okay? This one quite straightforward lah. It will be this. Yeah. Okay, for this one, look at the number 2. It means that uh, two oscillations or wavelengths are generated for every 1 second. So V equals F lambda 330 equals to 2 times lambda. And then I give you the answer for this. Make sure it's in meters. Half the frequency produces a sound half as loud. Half as loud means half the height. Half the frequency means 2 times the period. So let's put all these together. Half the height will be here. Okay, 2 times the period will mean that you generate 1 camel hump in twice the amount of time. Then it will be something like that. Yeah. Okay, so you get twice the period and half the height. So the changes will be half the height and 2 times the period. Yeah, that's about it. You can state any difference. Visible light has a lower frequency range than UV rays. Uh, it has a chance of killing living tissues or causing them to be cancerous due to its ionizing radiation. It could just damage. Yeah. So you either damage or you kill. The last part is cancerous lah. Cancerous is when you cause the cell to no longer listen to your brain and the cell just multiplies on its own. Over time, it becomes its own living organism separate from the human body, from the host. I was just telling my wife the other time, a tumor is simply uh, another thing living inside you, which is kind of true actually. Okay, the speed of the wave, in this case, you got to find the lambda and the frequency. The lambda in this case is actually 2. Time in this case, 0.02. All right, put this together. Make sure to inverse your period and multiply it with time. With the lambda, you get 100 meters per second. Always include your units in your answer. Sketch the new wave after half a period has passed. Half a period is 1 camel hump. Just remember that 2 humps make a camel. A period makes a period will have 2 humps. So draw half a period. This is 1 camel hump. And we're going to shift the whole thing by 1 camel hump, which will mean that it's like this. And we draw a new one inside here, fill in the space. This one would have gone here, and so on. So that's the answer. If the frequency of the wave increases, then the speed will increase. Okay, form an image IA on the object OA. F represents the principal foci. Locate IA. Okay. So first thing you want to do is draw what has not been drawn. Draw what you're aware of that has not been drawn. So the optical center has not been drawn. So put it in. The light ray parallel to the principal axis has not been drawn as well. And then you can draw this. Then you will notice that you want to cover the gap of this line. Okay, make sure to put your arrows. And then this would be IA. So your A has gone down. Your O should still be here. Okay. Uh, in this case, it's IA prime. All right. That's the first one. Complete the path to the image. Oh, that's easy. So just take from this one. If it starts at the head, it ends at the head. So continue like this. If it starts at the back, it ends at the back. And very importantly, include your arrowheads. And we're done for this. What would happen to the image when object OA shifted slightly further away from the lens? Um, the best one way you can do, let's say you run out of ideas, right? You could just shift it to yourself. So just draw a light one. So you notice that this, if you shift it to the back, this will still be parallel. So you still have this ray, this is fine. But this ray will be like this. So it form like that, and then it will form here, which tells you that it will become smaller and nearer to the lens. This is a new IA, so called IA prime prime. So it will be nearer to lens and smaller in size. So once you've drawn that, right, don't leave the drawing there, just erase it. So one thing you want to do is draw it lightly so it's easier to erase. That's the trick lah. You could do that or you could either just memorize it. Yeah. Or visualize it if possible lah. By visualizing, I mean like you know that this will remain the same. Visualize this line, how it's going to look like. It's going to tilt. So visualize it tilting and see whether you're going to get a smaller or larger image. And we're done. Yay, another exercise done.